Hello everyone, welcome to my channel. So today we're talking about my CNC Cartesian robot arm. Okay, and as you can see here, the copper elements of the robot arm, the chassis, if you will, are all 3D printed. I'm not sure where the models are, so I'm not sure if I'm able to supply them or put them on anywhere public. But anyway, so what we've got here is 3 axes, hence why it's a Cartesian robot arm. So we've got the Z axes, these two here, the Z axes, so going backwards and forwards, and then we've got the X axes, these two here, and then this goes from left to right, and then we've got this little stepper motor here controlling the Y axis with our different attachments that we can put screw on and off, obviously going up and down. Okay, so as you can see, we've got the ULN 2003 stepper motor drivers here screwed into just a little bit of 3D printed board. We've got the breadboard here, which is being power supplied by this old computer supply here, which I managed to scrap from a really old one of my parents' computers before they're throwing it out. And then this fan here, which is on top of an Arduino case, which is also 3D printed. As you can see, it's got it allows airflow there as well. Keeps it cool while the robot arm is running. So let's jump into the code. I'm using a library called XL Stepper to control the motors. Each stepper motor has 4 wires, and we're using something called full 4-wire control, which just means we're telling each wire when to turn on or off. This gives us a really smooth and accurate movement, which is obviously perfect for a robot arm. In the setup section, I'm telling the Arduino which pins are connected to the motors and the stop buttons. The buttons are wired with the internal pull-up resistors of the Arduino, so normally they're high and then they go to low when pressed. I'm also starting the serial communication so I can send commands from other applications or simply the serial monitor. And then I'm also setting the max speed of the stepper motors, as the lower the speed, the more torque the stepper motors will have. When a command is sent over the serial port, such as step X100, Y50, Z-30, the robot arm knows how far to move each motor. The code figures out which axis needs to move the most, and then adjust the speeds of the others so they can all finish at the same time. That way the motion looks smooth and coordinated. Once the command is received, each motor starts moving to its target position. A flag called moving is turned on so the code knows the arm is busy. While the motors are moving, the code keeps checking on the stop buttons. These aren't just emergency stops, they're placed at the end of each axis to make sure the arm doesn't physically push past its limits. If a motor reaches the end and the button is pressed, that motor stops immediately. It's a simple and effective way to protect the hardware and avoid damage, usually a technology used in 3D printers. When the movement is done, or if the arm isn't moving, it sends back a message saying ACK, which means acknowledgement, which just means I'm ready for the next command. It helps keep everything in sync, and it's what external applications rely on to know whether the Arduino is ready to receive another command. At the bottom of the code, there's a small helper function that pulls out numbers from the command, like the 100 in X100. It's a simple way to keep the command format clean and easy to use. So that's how the robot arm works behind the scenes. It listens for commands, moves smoothly, and has built-in safety checks to protect itself. Next, I'll show you how it performs in a real-world test. Here's a demonstration of the robot arm in practice, attempting to draw a square. So first up is the X-axis. So what is happening is the stepper motor is being controlled to first turn clockwise. So this moves the threaded bar, which the Z-axis is attached to, which moves the Z-axis away from the screen, drawing the first line. And then the Z-axis gets turned on, drawing the second line, and then the X-axis again in the other direction, turning the third line, and then the Z-axis again, drawing the fourth line in the opposite direction.